Yeah, good evening, Tisat. Can you check with your, did you watch the recording and complete this tutorial? Up to which one you have done? I think it's from this we had to start, I think. From sixth one, right? Okay, up to 5 we have done, so we had to start with 6, right? Okay. So number 6, so it's there are so many groups, functional group. So if you check the priority list, so you can check with a short notebook. What is the main functional group here? What is the main functional group? Out of all this, so there's COOH group there, and Cl, NO2, then CO, and then COOH. So out of this, which what is the according to the priority list? What is the main functional group? Higher priority of this, which one? Yeah, correct. It's COOH. So you have to start numbering from that side, giving lowest number to the functional group. So then you can write here 1, 2, 3, 4, 5. The longest carbon chain you have to select 5, 6, 7, 8. So there are 8 carbon, the longest chain, and this CH3 also act as C2 CH3 CH2, that is ethyl group. Ethyl group. So then this become oxo, because actually we can't name this as a ketone because of COOH group. So then Cl is chloro, NO2 is nitro, this is ethyl group, and this is oxo. If you want, I'll write near them. It's oxo, this is nitro, and this is chloro, and this is ethyl. So then we have to write all these four according to the alphabetical order at the beginning of the name. According to the alphabetical order at the beginning of the name. Can you write the? Can you post the answer on chat? Can you guess? Yes. So this the name ends in oic acid. The name ends in oic acid. Octanoic acid. So because of 8 carbon is octa. Because of COOH is oic acid. Because of 8 carbon is octa. Then the name ends in octanoic acid. Octanoic acid. But before that you have to write all the substitute groups or side groups at the beginning of the name. Yes. What should come first here? Ethyl, chloro, nitro, or alphabetical order. Not the number to which they attach. So you have to consider the alphabetical order. So what should come first? Chloro, right? Cine. So then is 5 chloro. After that, what is the next alphabetical order? Ethyl, right? 5 chloro, 5 ethyl. To the fifth carbon, there are two substitute or side groups attached. Chloro and ethyl. So then you can write here 5 ethyl. After that, 4 nitro. After that, 7 oxo. If you found that the previous recording, I think the previous ones, if you have any small doubt, even you can ask, I can explain again if you find it difficult, because you haven't done theory yet, right? But you can manage this. Otherwise, I don't think we will be able to revise the entire syllabus if I go parallel to your theory class. For nitro, 7 oxo. Yes. There's no phenyl group here. This ethyl group. 5-chloro. Why N come before now? These are the after chloro. You should get ethyl, right? Not phenyl. This is ethyl group. Phenyl group is C6H5. C6H5, or this, if benzene ring is attached, that is called phenyl group. Both this same. This is called phenyl group. So this is ethyl, C2H5, ethyl group. Ethanol, ethyl alcohol, C2H5OH. If you combine this, it become this is C2H5, that is ethanol, C2H5OH, like that. Ethyl alcohol, ethanol, C2H5, that is ethyl group. So then ethyl 4 nitro, wait, after that you have to write 7-oxo, okay. Without leaving a space, you write after 7-oxo octanoic acid. 7-oxo octanoic acid. Octanoic space acid. After writing octanoic, you have to leave a space. That is the correct name, right? Then number 7. So can you copy down that? When you're done, tell me. Right. Then number 7, I'll erase the screen. 7th one, how to write it? That's also, can you first, you should better select the longest chain and highlight the or encircle the substitute group, then you will not miss anyone. So anyway, the numbering should start from the main functional group. Now you can see there are many functional, the substitute groups here. There's a aldehyde group, this is bromo, this is hydroxy. So then this is called propyl group, because you have to select the chain with maximum number of side groups also, because when you number in here, sometimes you can go this way, 1 2 3 4 5. Now whether to continue forward or going down, so how to decide that? If you go down like that, this entire thing becomes one side group, and it's very difficult to give a name also for this. If you go down, then this entire thing becomes one side group. Therefore we get many side groups. So if you go down, it becomes 5 6 7 8, no, 5 6 7 8. But this also you get 5 6 7 8, same number of carbon chain, same. If you go forward or down, it's 8 carbon. But when you go forward straight line one, there are many side groups attached. So then this one you can erase, that also become a side group or substitute group, this entire thing. So this is called propyl group. What is called propyl group? And this is bromo. And this is called aldehyde group. When this become a side group, if this is aldehyde functional group, the name ends in L. So this is 4-mile. You can check in the short notebook. I have shared that with your group. The short notebook, I have given all this. This is hydroxy. So this is this type of question they can ask in their paper. This is hydroxy. Now can you write the name? You can the 8 carbon, same as that octanoic acid. Can write all the side groups at the beginning of the name according to the alphabetical order, and can you post the answer on chat? Yes. When you're done, tell me. Did you write the answer? Or you can post the answer on chat. Okay. 7, okay, let's see, 7 bromo, 4 formyl, 6 hydroxy, 5 propyl, octanoic acid. Yeah, very good, very good. Since the others are getting the recording, I'll write it here. So according to the alphabetical order, the bromo comes first. So we don't consider the number, only the alphabet, the first letter of the substitute group. 7 bromo. And there's no rule, you have to write, start with the capital letter, right? You can write everything in simple, no problem. And after that 4 formyl. Then you get 6 hydroxy. So when you're writing, the most importantly, no gaps here. Between the around the number there's a hyphen or line, two small dash, but after writing hydroxy, then you have to write 5 propyl before the number, and after the number you have to put a small dash. 5 propyl group, propne 3 carbon, 5 propyl octanoic acid. Octanoic acid. So you had done it well, very good. And after writing octanoic, you had to leave a space. So that's how you write the IUPAC name, or International Applied Chemistry. So the IUPAC name of organic compound, so it's carboxylic acid. These are called carboxylic acid. So carboxylic acid having higher priority than the other groups in this. That's why the other groups becomes substitute groups. Then next one, acid chloride. Actually, acid chloride means in this COOH group, if you replace with this OH group, the COOH group, the OH, if you replace with a halogen, if you replace this with halogen, halogen means what? Say chlorine, no bromine, no iodine, like that. Then so this becomes COCl. If I expand that, and then it will be like this CO. So around carbon there must be 4 bonds, ne? Then will be like this C double bond O Cl. So that is called acid chloride. So this is a carboxylic acid that is this is called acid chloride. So actually it's a derivative of carboxylic acid. So this is a derivative of carboxylic acid. OH has been replaced by halogen. So if it is Br, we call it acid bromide. If this was Br, we call it acid bromide, like that. So then those ones, the name ends in oil chloride, right? Octanoil. Now this oic, this is oil chloride, octanoil, hexanoil chloride, like that. That's how you end the name. The rest of the things same as before, nothing new. The others same as before, the other rules. So we'll continue now. I think if you want to, I don't know whether have you got the soft copy of this the resource book, organic chemistry? You can get from the NIE website also the soft copy, or if you only can get a printout, even if you go to the bookshop NIE or ISRUPA, so then you can get the resource book hard copy also instead of photocopy. Wait, I'll share that with you. Organic unit 7 to 10. Yeah, so they have given here. So you can see this carboxylic acid, the one we discussed just before. So that's oic acid. Can you see here? So this one they have named as oic acid. 3-oxo-4-hexenoic. Now because why is hexan instead of hexanoic here, hexenoic? Because of double bond. Why 4-hexenoic or 5-4-enoic? Double bond begins at the 4th carbon. Double bond, the alkene like double bond begins at the 4th carbon. So I don't know whether they have given oil chloride, acid chloride. Let's see. They will never ask these rules, right? They have given here the list, the rules here, the principles, the stepwise approach to build the IUPAC names of compound and other than hydrocarbons. So that one, they will never ask these rules, but they will give the structure and ask you to write the name. So IUPAC name, they have not given, I think, oil chloride. alcohol given, carboxylic acid. There are some examples they have not given actually here. They have given mainly carboxylic acid as alcohol, as alkene, alkyne. Yeah, carboxylic acid. Anyway, I'll continue that one also, because then you can manage anyone given in the exam. The priority order, you can get that name here. As a order, the priority. They have a long paragraph here, but no need to memorize all this. So this is ethyl methylamine. This is a common name, right? You know, derivatives of carboxylic acid, there are three. Can you see here? That is acetyl chloride. Acetyl chloride means it's like acetic acid. Right? Acetic acid become acetyl chloride, but normally IUPAC name we don't use acetic acid. So we call it ethanoic acid. You can see here CH3 COOH. So it has become CH3 COCl here. CH3 COCl. This is acetic acid. But that is a common name. Right? So but we call it ethanoic acid. Eth means 2 carbon. Ethanoic acid. This is ethanoyl chloride. That is called ethanoyl chloride. So acetyl means this is 2 carbon here. That's why. So ethanoyl chloride. Ethanoyl chloride. So this is ester group. Therefore, carboxylic acid can be converted to any of this. So this is the ester. This is amide. If you want to write that separately, wait, I'll share this one. You can get even aromatic ones also. You can get like this. Aromatic one. This is called formic acid. HCOOH. That is the simplest carboxylic acid contained in 1 carbon. So this formic acid is also called methanoic acid. Meth means 1 carbon. Methanoic, methane. Methane is CH4. CH4 methane. Methane. So this is methanoic acid. CH3 HCOOH. This is the expanded one displayed. That is also called formic acid. Formic acid commercial name, like common name, but this is the methanoic acid. Methanoic acid. So acetic acid is what? That is called ethanoic acid. And this is an aromatic one, benzoic acid. Sodium benzoate is used as preservatives also. So you can I'll go summary of this. These are again this alkyl halide. These are they have given for each they have given few examples of these compounds. Acid halide. So this acid halide means it's same as if it is chlorine. Halide means halogens. Halide means halogens. Group 7 elements. Carboxylic acid, it can be replaced with either chlorine, bromine, iodine. So here is chlorine. Halide. Halide means halogens. Halogens. Fluorine, chlorine, bromine, iodine, right? I will. So how they are derived? They are by replacing OH group. By replacing of OH group of the COOH. By halogen no, by OR, that is for the ester, and NH2 to make amide. I'll go summary of this. You can copy down this in your writing book if you want. Tisat, have you done this in theory class or in school? The organic compounds are you basically not yet, right? Organic chemistry, have you started? Not. Not yet. No. What? But you can manage what you can understand what I'm explaining, right? Because it's not a big thing. You can refer the resource book, and but no point of memorizing any of this example. When you are given the name, you should be able to write the name. When you are given the structure, you should be able to write the name, and when you are given the name, you should be able to build the structure. But the thing is, those acid chloride, and they have not given examples, I think, here. Yeah. And amide also, they have not given the IUPAC name. Carboxylic acid, aldehyde alcohol given. So all what they have given in the resource book we have done up to now. But there are two more things, nitrogen containing organic compounds, and now this is the priority order. So that's what I told oil chloride. Can you all see, this is very important. This page number, resource book page number 17. Right? Page number 17, this is very, very important. This one you have to remember. This is very important. You should better take a printout of this. But anyway, I have given that in the short notebook also. So you can see, sorry, you can see here acid chloride, that is the third highest priority after ester. The highest priority carboxylic acid. So in the presence of carboxylic acid, then all this become substituent group. But in a compound, you cannot have carboxylic acid and the ester and the acid chloride all three, like, because one of that only. So out of these, that's why here that they are not considered as substitute groups. So these ones, only one of these could be present in organic compound, but the others could be present with any one of these. So all these are derivatives of carboxylic acid. What are these called? Derivatives of carboxylic acid. These are called except COOH. Except COOH, the others are called derivatives of carboxylic acid. Derivatives of carboxylic acid. What are these? Derivatives of carboxylic acid. Derivatives of carboxylic acid. What are those? Amide, acid chloride, and esters. So they have the highest priority in the list. And when you write the name, the suffix, so it's end in oic acid, that we had this. So oate means ester. So this is what I told, oil chloride, ethanoyl chloride, methanoyl chloride, like that. Okay, so I will give this example. I'll give this example also, then you can copy down this in your writing book. If you take, say, CH3 COOH, we can get from this say, acid chloride. This is the carboxylic acid. Carboxylic acid. So it can be converted to CH3 COCl. Then it's become acid chloride. Then next one you can write, this is called acid chloride. The next one you can write amide. CH3 CO, then OH can be replaced with NH2. Better copy down this. OH can be replaced with Cl, then is acid chloride. OH can be replaced with NH2, then is called amide. The third one, you can replace this with ester group. We can write CH3 CO CH3. So this is methyl ethanoate. This CH3 OCH3. OCH3. That means OH group replaced with this is the OH group. This replaced with Cl. Here replaced with NH2. Here replaced with OCH3. So this is called ester. This is called what? Ester. Ester 1, 2, 3. So if you write the name here, this become acetyl ethanoyl chloride. Ethanoyl chloride. This is acetamide. That sound we call it ethanamide. Ethanamide. Commercial name we call it And that previous one also you can write here ethanoyl chloride, or instead of the common name you can write acetyl chloride. Acetic acid, this is acetic acid, carboxylic acid is also called ethanoic acid or acetic acid. Ethanoic acid, example, this example I have given ethanoic acid, that is also called acetic acid. And this is example, it's vinegar, right? Vinegar in the kitchen. So like that, this also you can write acetyl chloride. Acetyl chloride. And this is ethanamide, that is also called acetamide. Acetamide. This is methyl. This CH3 is methyl here. This group is methyl. Methyl. This part is called ethanoate. Methyl ethanoate. That is ester. Methyl ethanoate. This is called say example, if it is CH3 COONA. Sometimes you can write this this like a derivative. You can write this way also. I'll give one more here example. You can write here sodium salt of carboxylic acid. 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 That is so if you write this, it's CH3 COONA. So we call it how to write the name for this sodium ethanoate. Right? Sodium ethanoate. Sodium ethanoate. Sodium ethanoate. Sodium space ethanoate. That is also called sodium acetate, because its acetate word is there, right? Acetic acid, acetyl chloride, acetamide. So if you want to write here, this one even methyl acetate. This also you can write if you want methyl acetate. Methyl acetate. Methyl acetate. And this one you can write sodium acetate. Sodium acetate. Both are accept. Sodium acetate is common name. Methyl ethanoate, acetamide, acetyl chloride. That's commercial. But IUPAC name, like you have to use the word two carbon, ethanol, ethanoic acid, ethanol. Like that, you can go through. Like even if you take the prefix, you can have the same thing here. CH3 COOH, ethanoic acid. Right, ethanoic acid. So that also you should better remember this. So example, you can write CH3 ethane. Okay, done. So then, okay, this is what I was trying. CH3 ethane. Then CH3 say COOH, ethanoic acid. So we'll go like this. We'll first write. I'll write ethanol. So CH3 CH2OH, ethanol. then CH3CHO, ethanol, right? Then CH3, these are the main functional group in your organic chemistry. CH3, CH2, Cl, ethyl chloride. I'll write that one first. CH3, CH2, it's called alkyl halide. Halide means halogen, CH3, CH2, Cl. Then CH3, CH2, CH3, CHO, aldehyde, acetaldehyde or ethanol, ethyl chloride, ethanol, ethane, okay, I'll write here ethane. This is ethanol, alcohol. This is ethyl chloride, alkyl halide. This is ethanol, ethanol. Then you can write here CH3COOH, ethanoic acid. So all this ethanoic acid. Ethanoic acid. Ethane, ethanol, ethanoic chloride, ethanol, ethanoic acid. Then you can write CH3, CO, NH2. So this is called ethanamide. Or we can write this way also, wait, ethylamine. So I'll write here CH3, CH2, NH2. So that is called ethylamine. Ethylamine. Or we call it ethanamine. Then CH3CO NH2, ethanamide, ethanamide or acetamide. All this you can use that aceto word also, acetic acid, acetaldehyde, acetylamine, acetamide, like that. But anyway, but I don't prefer that one, because IUPAC name you had to use eth word, ethyl, because of 2 carbon. Like that I can write many more, at least the ones in your syllabus, major ones, so you have to remember this. Any other you can start with it, or you can start the same thing with propane, propanol, propanoyl chloride, propanol, propanoic acid, propylamine, and propanamide, like that. Is that clear, the pattern? Or you can write, if there are 4 carbon, butane, butanol, butyl chloride, butanol, butanoic acid, butylamine, butanamide, like that. So the only thing is the prefix will change, that's it. Actually organic chemistry is not very easy, because that's why I thought of doing this first before you start that in the theory or the paper, even school, because then only like I can make it like the students will get that idea, so it's easy. Otherwise, if you had done this and come, then if I did, then you will have that attitude like it's going to be hard. So you have done this before, so that's why I thought of doing organic field, because no balancing, right? No balancing. Organic chemistry, we are not going to balance the equation. Inorganic chemistry, you don't balance. Organic chemistry, we are not writing byproducts. Organic chemistry, you are not getting calculation. Organic chemistry, we are not writing the physical state. Therefore, organic chemistry, you get all A-level, I mean, structured essay 1 complete question. Structured essay question number 4 completely from organic. So structured essay you get 1 complete question organic, and essay type you get 1 complete question organic, and you get around 12 to 13 MCQs also. 12 out of 50 MCQs, 12 to 13 MCQs also from organic. So nearly 30 to 35 marks of the out of 100 in the paper. Therefore, it's very it's easy to get this marks. So if you should not give up the organic questions when you are going to select essay type questions. Even if you are good in organic chemistry, you can quickly do it and save time to do the other, especially physical chemistry, energetics, and all this kinetics calculation. Then calculation, it takes more time. Right. Then shall I erase this? This green one, shall I erase? So you should better keep a separate short notebook for organic. I mean, then you have a set of very useful short notes at the end. Right. Okay. Then one more thing. Now this is aliphatic one. If you want, you can get aromatic one also, like this. So example, look at the screen. You can go like this way also. You can get say benzene. You can get this benzoic acid. Then you can write benzoyl chloride, that's COCl. Same thing you can have aromatic. This is called aromatic. This is aliphatic, the left side one, pink one. So this is called aromatic. Most of the medicines, most of the enzymes, most of the polymers, like they aromatic. So most of the things in the nature aromatic. Most of the medicines, even hormones, vitamins, enzymes, or aromatic groups there. This is called benzene ring. This is C6H5. C6H5COOH. This C6H5 is also we can represent like using is an aromatic structure. C6H5, that is called benzene ring. Actually, this is how it's arranged. If you want, I'll draw it here. There are 6 carbon, cyclic one. This is acyclic. This is called acyclic, or this is called aliphatic. What is the opposite of aliphatic? Aromatic. What is the opposite of acyclic? Cyclic. So these are cyclic. They are aromatic. Aromatico, cyclico, all these aromatico, cyclic organic compounds. Cyclico, aromatico, yeah, opposite of aliphatic is aromatic. Then C6H5 group is same as this benzene ring. If you were to draw here, I'll draw it here. So this is called benzoic acid. So you have 6 carbon arranged like a ring structure, like this. Ring structure, like a hexagon, like this. You can check there are 6 carbon atoms here. There are 6 carbon atoms. Okay, like this. So then you can have C6. Then you get here H5. And here you get COOH group. So, but then there must be around each carbon there must be 4 bonds. Therefore, alternatively we put double bonds here. So you can check here how many around each carbon atom. Now there must be 4 bonds. You can check. If not, tell me. Around each carbon atom. That's what we write as C6H5. That's why we call it C6. This is the detailed displayed formula. So this entire thing is called C6H5. Entire thing means this part. I'll highlight this with a different color. I'll highlight this. This one. This is called C6H5. Is that clear now? So we can write as C6H5 and then the COOH, that is called benzoic acid. This is aromatic organic compound or aromatic carboxylic acid. But in the detail class they will teach this in detail, but just to understand the name and the formula or the structure, right? if you only can copy down that. So what is this first one? So benzoic acid is benzoic chloride. Then this one, you can write CONH2 here, same as that one, benzamine, benzoyl chloride, benzoic acid. Then you can write COONA, sodium benzoate. I think most of the canned food you might have heard this. Sodium benzoate is used as a preservative. Sodium benzoate. What is sodium benzoate? Sodium benzoate. Right, like that. But anyway, this aromatic one, you will not get the IUPAC names under your syllabus. So only aliphatic ones you are getting. Okay, that was very important. Aromatic organic compounds, you will not get IUPAC names in your syllabus. Only aliphatic ones. Therefore, no need to worry about. But anyway, if they are given the name, you should know what it is. That's enough. That this list also, if you only can copy down. When you're done, tell me. It's called benzoic acid. Benzene carboxylic acid. Example, if you take, I'll give one example. If you take a glass bottle, it is inorganic. If you take plastic bottle, it's organic, right? Now imagine you are going to check the, imagine you take sample of water from a well and you want to do a, SLSI or ITI, you want to check the parameters of this inorganic compounds in water sample whether it's suitable for drinking. So then you should use a glass bottle. Not glass, organic one. Plastic bottle you use, if you're going to check your organic compound, you should not, you have to use a glass bottle. Glass is inorganic, therefore you are going to check organic here, therefore no contamination. Now imagine if you are going to check the inorganic compounds in this, you are going to analyze, check the quantity or concentration, then you fill the water into a plastic bottle, plastic organic. So you're going to check the inorganic, therefore no contamination from the bottle to water. So that's something like that. Therefore even organic things you should not use organic containers, because organic because same similar chemical properties, so therefore they can mix up, can contaminate. So example, I'll tell one example, coconut oil organic, therefore it's better to use a glass bottle for storage of coconut oil than plastic, polythene or glossary bag. Sometimes people are carrying polythene into coconut oil in polythene bag also. That's not good, right? Something like that. Right, then shall I erase this? Did you copy down everything? Since we have not done theory, I explain this part, because otherwise like just you are just copying down the name without knowing them. Yes, okay. So I'll erase this. Then let's move to the next part. I think we had to start with see whether you have you got a printout of this, or you are using the soft copy. This is the 7.5 tutorial, and organic is the last tutorial. The soft copy, so if you only can copy down the structure in your writing book and write the name, then not to take a printout. No, these days with the printing cost and all, like it's better to use your exercise book and just copy nothing much to write, no, just the structure and the name. Therefore you can just write 7.5 organic IUPAC names, and then nitrogen, this is nitrogen containing organic compounds, write in the names. Tisaj, you got disconnected, no? Can you hear me now? Right, okay. So then we'll continue this one. Nitrogen containing organic compounds. So nitrogen containing organic compounds, there are two types. So one is amines and the other one is amide. Amines and amide. I think the previous one didn't finish. Wait. Acid chloride we had to complete. No, before that. Yeah, sorry. Yeah, 7.4 we have some. Okay, sorry. We had to start with, okay, acid chloride we had to do first. Okay. So acid chloride, you can, the name ends in oil chloride. The name ends in oil chloride, and the other rules same as before, nothing new. The other rules same as before. So it's ending, the name ends in oil chloride, that's the only change. And it's the priority we give to the COCl group. But in the exam, A-level pass paper, so I have shared that also with your, I think, this paper. You can try this at home now. This from 90, look, can you see the screen? From 1995 A-level until 2017. I have given last 20 years. 20 means altogether 22 years, no? 1995, 2005, 2015, 20, yeah, 22 years papers. I mean IUPAC names of organic compound. Every year you get a question from this, so you can try them at home now, right? Because you learn the techniques now. You can, have you got a printout of this now, right? Past paper questions, not yet. So in this one, either with the printout or without the printout, you can just copy down the instruction, keep it ready. I'll try to. Okay, so I will try to do one or two today. I'll explain to you this time. If not, you can try this at home. Next week I'll discuss. Right. 7.4 acid chloride and nitrogen containing organic compounds. They have not asked much. You can go through those questions last 22 years, even the last few years papers also. They don't. They have not given much questions from this. They have not given much questions from this. Okay. Anyway, we'll see now this one how to write the name. So the first we have to identify the longest chain, longest carbon chain contain maximum number of carbon atoms. So here is 1, 2. You have to start. This is acid chloride. COCl will be the functional group, and the others will be the side groups here, substitute groups. NH2 substitute. Then you can go for either you can go forward or downward, so you get the same number of carbon atoms. 1, 2, 3, 4, 5, 6. So even if you go down like this, 5, 6, same number of carbon atoms. Therefore no change. Therefore I'll erase this and take the linear one, and this becomes the ethyl group, side group. Ethyl there, and NH2 is called amino. MH2 is called amino. Then how many carbon in the longest chain? Hexanoyl chloride. So how to write the name? Hexanoyl chloride. Hexanoyl chloride. Right, that's how you write the name. Okay, we'll write now. If you can post the answer on chat. What should come first? Alphabetical order. This is ethyl. This is amine. What should come first? Amino or ethyl? Alphabetical order. Amino should come first, right? So to which carbon amino group is attached to the third carbon? Therefore you get 3 amino. 3 amino. Then yeah, it's amine, but when it becomes the side group or the substitute group, we call it amino, like is amino, right? Yeah. Amino. Then 4 ethyl, 4th carbon ethyl group is right. After that hexa, 6 carbon in the longest chain. Hexanoyl chloride. Hexanoyl chloride. Hexanoyl space chloride. Then number 2. Can you try the next one before me? Number 2. So you can go like ethanol chloride, but methanol chloride, propanoil chloride like that. Okay, you have also so 3 nitro 4 phenyl, 3 nitro 4 phenyl hexanoyl bromide. What about the CHO group? You can take this one you have, Miss Tisat. Wait. Okay, this I'll highlight this. So this COBr bromide then, this is not chloride, is bromide. Hexanoyl bromide, not bromine, bromide, hexanoyl bromide. Then you have to select the longest chain with the maximum number of carbon and atoms and with the maximum number of side groups. Ne? So I'll highlight here, this is nitro group, NO2, and this is phenyl group, phenyl group. And this one is now, okay, let's see the numbering now. 1, start numbering now. 1, 2, 3, 4, 5. Now next one is whether we take this one as a side group or whether we go up to that one, right? So that's the other problem. So actually you should go this up to this carbon, 6 carbon, then it's become oxo. I'll expand that and show you. It becomes like this, C double bond O H like this. Right. So then this become what? If you take this one as a to the longest chain, this become oxo. Did you get it? Can you try again? This become oxo. Oxo. This become phenyl. And you can. This is nitro group. Nitro. This is oil bromide. The name ends in oil bromide. What oil? Hexanoyl bromide. Hexanoyl bromide. Hexanoyl bromide. You have to leave a space and write bromide. I think Sinhala medium also IUPAC names you can't write in Sinhala. You have they write that this in English, I think. Right? Even Sinhala medium students and English medium students. Because IUPAC name international that we can't convert into any other language. It's like the scientific name of animals and plants. Can you try again this number 2? Okay, you have given 6 nitro, 3 nitro, no, 3 nitro, 6 oxo, 4 phenyl, hexanoyl bromide, not acid, hexanoyl bromide. Yeah, correct, very good. Only thing is not hexanoyl acid, hexanoyl bromide, because Br is bromide if it is Cl chloride. And I'll write it because the others are getting the recording. So I'll write here 3 nitro to the third carbon, 3 nitro, then 6 oxo, then 4 phenyl, then you get hexanoyl. Now most of the, even if you check the internet, I think they use hexanoyl NOYL, but if you write NOIL also they'll accept both, I think. Yeah, I'll write YL because in the resource book they have gone in OYL, hexanoyl space bromide. So only thing you have not put bromide. The rest is correct. Okay. That's the answer. Shall I read this? Then next group of organic compounds, so under derivatives of carboxylic acid, esters. So esters, so the name ends in O8. You can check in the resource book, I will show that. That is, it's, you can see here, it's end in O8, O-A-T-E. That is the highest, second highest priority of carboxylic acid, O8. So ethanoate, methanoate, like that. Propanoate, butanoate, pentanoate, hexanoate, heptanoate, like that. We know the prefix based on the number of carbon atoms, and the name ends in O8. So that is called the the homologous zero, that is ester group. So let's see now. So it's not a continuous carbon chain, Tisas. That's the main. That's one of the main difference here. It's not a continuous carbon chain. You can see here. This side you get the C. Okay, I'll highlight this. This HCOO. That is the main part, and that is the main root. So and that is not directly attached to the CH3 group. That is not directly attached to the CH3 group. Okay. Then you have to write it. CH, so you get here H, you get here H, C, double bond O, then you get O, O, sorry, only one no, this C double O is there are only 2 oxygen atoms, and after that there are 4 bonds around this carbon atom, right? After that you get the CH3 group here. Now you can see this CH3 group is not directly attached to the carboxylic acid. It's attached to the carbon through the oxygen. Therefore, when you are numbering, you can't continuously number 1, 2, 3 like that. You can't go here. You understood, right? Because carbon chain, when you are numbering, it has to be connected to each other continuously. Therefore, the main one this is actually methyl group here. This is the methanoate. This is called methanoate, right? Not methanoate. This is methanoate. This is methanoate. Only one carbon. Therefore, methanoate. Methanoate. Methyl space methanoate. Methyl space. Why? Why methyl space? Because methylic group is not directly attached to that carbonyl carbon. This carbon is called carbonyl carbon. That is called carbonyl carbon. This is called carbonyl group. The COO group is called carbonyl group. This carboxylic acid has this carbonyl group. If you want to note down this, separate in the right book. This is called carbonyl group. So that's a very useful functional group. Carbonyl group. Carbonyl group, and this is called carbonyl carbon. It's a polar group. Even acetone, most of the compound this group is there. If you take aldehyde, this group is there, carbonyl carbon group, and carboxylic acid also this is there, right? Amide also this is there, and esters also this is present, and even acid chloride also this carbonyl group is present. Therefore, most of the organic compound this is present. CO, say Cl, that is called acid chloride. Acid chloride, this is called aldehyde. Aldehyde group, then both this aldehyde. I'll make this ester group. Aldehyde group, ester group, then carboxylic acid group. Carboxylic acid. This is carboxylic acid. This is carboxylic acid. Then this is amide. This is acid chloride. Then if you want to write here sodium salt of carboxylic acid, COONA, ONA. So this also, this carbonyl group is there. This is common to most of the organic compounds. Carbonyl group. Carbonyl group. Even this is present in esters also. If you take, like, most common, the nail polish remover acetone, CH3, this is called propanone. We have done the IUPAC nomenclature of ketone. So this is a ketone. Ketone is the main group, and this also has the carbonyl group, and this is called propanone. Prop means there are 3 carbon. Prop means there are 3 carbon. It's a ketone, therefore propanone. And this is also, within bracket you can write acetone, the commercial name, like acetone, common name. Acetone, like acetic acid, like that. Acetone. So this you better copy down this also if you want. Now this carbonyl group is very important because this is a polar group, and that most the functional properties, so the properties of this organic compound depends on this group because it's a polar group. Because CH3 groups non-polar group, CH3 is non-polar, so that is an hydro, if you take this CH3COOH, or this is the non-polar part, this is the polar part. So this CH3 group is hydrophobic, polar, non-polar and hydrophobic part. Non-polar means hydrophobic, and the COOH is a polar group, that is hydrophilic group. It can form hydrogen bond with water. COOH group can form hydrogen bonds with water, that is called polar group, and it is a hydrophilic group, Jalakarshaka, hydrophilic. So because of the COOH group, it can form what? Hydrogen bonds with water. That's why carboxylic acid soluble in water, because of the formation of hydrogen bonds due to the presence of this OH group. So those things also a bit important. If you want, you can copy down in your short notebook. Most important things I am telling, the rest you will get in the theory class. Hydrophilic and the hydro. So what happened is, with the increasing of the carbon chain, this side the length increase, the hydrophobic. Example I'll tell, hexanoic acid, what happened now? Hexanoic acid, you get CH3, okay, CH3, CH2, 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 how many carbon now? 1, 2, 3, 4, CH2, COOH. So this is called hexanoic acid. Hexanoic acid. Hexanoic acid, what happened now? The non-polar part, non-polar hydrophobic hydrocarbon chain is more now than the COOH, because then it's become more significant. Therefore, solubility of hexanoic acid is less than the ethanoic acid. Did you get the point now? Because when the carbon chain increase, the solubility decrease, and the boiling point, melting point also bit increase because of the increasing of the relative molecular mass. This ethanoic acid has 2 carbon and only 1 CH3 group. This one having more hydrocarbon chain, that is hydrophobic part is more significant. So, but still slightly will dissolve, but solubility is less. Is that clear, Tisa? Therefore, some molecules you can't tell exactly is polar or non-polar. It has both the properties. So, the most significant group is COOH group. The functioning of this compound depends on the COOH group. Functioning of this compound depends on the COOH group. That's why we call it a functional group, COOH group, carboxylic acid group. That's why it's so the water solubility, the boiling point, melting point, those properties depends on that COOH group. Even though it's small group, it has more significant influence towards the properties. Right? I hope you understood those points. If you want, you can copy down any of this separately in your short notebook. Done? When you're done, tell me. Done? Shall I read this? Right, I'll erase this. Then let's move on to the next one. So this one, what is the name now? So first you write here methyl group, and then this side methanoate. There's only 1 carbon, methanoate. So I'll write here methyl methanoate. Methyl space methanoate. Then next one, this is again methyl group. methyl group, and then this one, how many carbon? There are 2 carbon, therefore it's ethanoate, methyl ethanoate, methyl ethanoate. The next one, C6H5 phenyl, phenyl methanoate. This is a phenyl group. It's not directly attached to the carbon of the other side, so then it become phenyl methanoate. Next one, this side ethyl, ethyl, CH2 means ethyl, ethyl methanoate, ethyl, and this one is methanoate, only 1 carbon. This is actually what is called methanoic acid. HCOOH is all for methanoic acid, methanoic acid, only 1 carbon. If it is CH4, methane, methane is methanoic acid, HCOOH. If you expand, it will be like this, HC double bond O, this carbonyl carbon and the carbonyl group, and this is OH, and this is also called sometimes formic acid. What is the common name? Formic acid. The ants, when ants bite this, they inject this to, that it causes severe pain. Formic acid. Some you get formalin, formaldehyde, formalin, it's like this. Then ethyl methanoate. Right, done. When you're done, tell me. I'll erase after that. Right, then next one, I'll erase this. Then number 4, what? Ethyl methanoate. No, this is ethyl methanoate. I did right, yeah. Then you get number 5. Number 5, you get ethyl. This side is ethyl, and the other side you get 1, 1, 2, 3. So it's propanoate. What is propanoate? This is ethyl group, and this is propanoate. So you write here ethyl space propanoate. Propanoate. The next one, this one can you try alone? This one you have to be very careful, right? So this number 6 bit different from the previous one. Carboxylic acid they can ask in the exam, right? So this one same as before. First you have to try the methyl group because it's not attached to the main carbon chain. So you write here just methyl. After that, after writing here methyl, then you have to number the carbon chain. Look at this, 1, 2, longest chain, 3, 4, 5, 6. So that hexanoate. But before hexanoate, there are 2 side groups attached, substitute groups attached. One is bromo, the other one is phenyl group. Bromo and phenyl. Then you can write here methyl. Before you write hexanoate, you have to include the substitute groups. What? methyl space 3 bromo 3 phenyl, 3 bromo 3 phenyl. After that you can write hexanoate, no space here between phenyl and hexanoate, no space between phenyl and hexanoate. Did you get it? Okay, when you're done tell me. Okay, have you done? Shall I erase? Right. Then can you do the next one alone without my help? Try first. Number 7. Number 7, can you try first? After that I'll, because it's similar to the previous one. Yes. When you're done, post the answer on chat. Okay, you have given methyl space 3 ethyl pentanoate. Correct. Very good. Very good. Answer is correct. So I'll write it down. 3 ethyl. Sorry. Methyl space. Methyl space 3-ethyl pentanoate. The last one also, okay, there's a small change now. For you got methyl at the beginning. Now this one is potassium. You can write, start with this potassium space, and the rest is same. Can you try it alone first? If you want to highlight the side groups, substitute groups, you can try it. Yeah, okay, you have put potassium space 3-methyl 3-phenyl pentanoate. Yeah, correct, very good. Potassium 3-methyl 3-phenyl pentanoate. Yeah, correct. I'll write it these since the others are getting the recording. Right. I'll give two more, like one more to do it alone. This is can you try this without my help? I'll write it. You can copy down this. This one, can you write one more example? CH3 CH2 CHCl CH3 CH2 CH2 COONA. Yeah. What about this one? This one, can you try? Can you post the answer on chat? Okay, sodium, again, sodium space 4 chloro 4 methyl hexanoid, correct, correct. Okay, this is good. And next one also, is 1 2 3. I'll write the name anyway. 5 or 6. Sodium. Yeah, this one also can write this one. This is not a ester. Be careful. This is acid chloride. This is phenyl group. Huh? This C6. This is same as C6H5. That is called phenyl group. And try write even the answer for this also. Okay, you have given 4 phenyl, 4 hydroxy. Now, so this one, okay, what you have done is correct, but it's acid chloride, right? 4 on X hydroxy 4 on. So this is oil chloride, right? Because it's acid chloride is a This pentanoyl chloride. It's pentanoyl chloride. Pentanoyl chloride because it's acid chloride. Pentanoyl because of 5 carbon, and oil chloride because of the acid chloride. And the other more important now, your name, this alphabetical order, you have put 4-phenyl first. So what should come first, phenyl or hydroxy? This is hydroxy. What should come first, alphabetical order, H or P? 4-hydroxy should come first, or 3-phenyl? 4-hydroxy, right? Yeah. So you can try again. Can you try again now before I write? Try again once. Name ends in pentanoyl chloride. Yeah, okay. Now it's correct, right? Yeah, 5-hydroxy or 4-hydroxy come. It's 4-hydroxy, right? One, two, three, four, five. Yeah. I think number in again. Yeah, it's 4-hydroxy, right? And 3-phenyl. Yeah. Because if one go wrong, no marks in the exam, no part marks in the error marking for this. You write it perfect because no part marks. Imagine now doctor is writing a medicine. So one letter difference, the medicine will change. That you are dealing with the life of a person, then the medicine will change, means you are giving the wrong medicine to the patient. Then what happened? It can cause even death. Right? So that's why when writing the medicines names or the pharmaceutical industry, one letter difference can change the medicine. That's why you have to write it perfectly. So mostly in Sri Lanka, what happens? Whatever the medicine doctor writes, sometimes no one can understand. Even pharmacy person also can guess it and ask, "Did you get the medicine for sore throat?" Like he has some. If they are not used to the letters of the doctor, that's why next to the doctor's the pharmacy, sorry, the dispensary or whatever the clinic, next to that there's a pharmacy. They are familiar with the doctor's writing, handwriting. So otherwise, no one can understand their writing. Sometimes doctors the prescription. But anyway, sometimes there are many cases. Sometimes the pharmacy they can't understand what they have written, then they give wrong medicine or sometimes. So therefore, it's very important, that's you are dealing with the life of a person. Right? That's why no part marks. So if you have done a simple mistake, they will not give marks at all. 0 marks. That's why. So this way you have to write it perfectly. Okay, so I'll write it name now. How to write this? 4-hydroxy. Anyway, this you can't study or memorize. You have to learn it by doing it. You have to practice this by writing the IUPAC names of many examples alone and check with the teacher. Right? Then only you will improve. Otherwise, you can't just read it and memorize like the other theory. Okay, 4-hydroxy 3-phenyl. 4-hydroxy 3-phenyl pentanoyl chloride. Pentanoyl space chloride. Okay, what about the other one? I have given one more. Can you try this number third one also? That also oil chloride. Can try it before my help. Without my help. First. Number 3, third one. Right. Okay. So you have sent 3-ethyl 4-oxopentanoyl chloride. Pentanoyl and not acid, chloride. Chloride. You can't tell acid. Okay. So this is also acid chloride, COCl. So I'll write the number now. Carbon chain 1, 1, 2, 3, 4, 5. Right. Then substitute group. So this is ethyl and this is oxo. Okay, so what should come first, ethyl or oxo? So this 3 ethyl and 4 oxo. Then you can write here 3 ethyl, 4 oxo, pentanoyl chloride. After oxo no space, uh, pentanoyl chloride. Okay, so I think it's correct except that pentanoyl instead of acid you have to write chloride this. Right? So that's the answer. Okay. So like that you need to practice a few more, but anyway you have the separate, like the last 22 years papers I have given a separate one. You can try them because it's like now we discuss carboxylic acid separately. Now last week we did aldehyde and ketone IUPAC names. Today we did carboxylic acid, acid chloride, and then now we are going to discuss about nitrogen content in organic compounds. So but in the exam, like randomly you can get it, therefore in the past paper, so that the other tutorial you have to go through this also. If you have a doubt you can refer each section what you have done now. Then next the next tutorial, nitrogen, that's all. This one, nitrogen this one, that's all. No, we discuss everything. Then 7.5, nitrogen containing organic compounds. So this is how you should write the name. Traditional name you can write ethylamine. So this is called methylamine, ethylamine like that, methylamine. So this one you can write ethylamine, but IUPAC names you can write like that. So you can write methanamine, methane, methanamine. That's how you write it, methanamine. So this is ethanamine, ethanamine, ethanamine. Then this one you can see the CH3 group is attached to the nitrogen. Then we write it what? N-methyl, N-methyl, N-methyl. Then you can see the other one is ethanamine, N-methyl ethanamine, N-methyl ethanamine. So without leaving a space you can write N-methyl ethanamine. If you write here methyl ethylamine, but this is the IUPAC one. Then shall I write this? But this one not much important because they haven't asked from this section the past paper questions. Even in the resource book they have not given even a name. But anyway, this is a complaint. Everything completed now, whether either you get or not. So you have done everything, but then no need to worry. From whatever the section you are getting questions, you should be able to manage. That's why to make it a complete note, I gave this also. Okay, done, no? Right. Then next one, number 4. Number 4, you can see this is the longest chain this side, that means propanamine, but to the nitrogen this ethyl group is attached. Then you write here what? N-ethyl, propanamine, N-ethyl propanamine. This one now, there are two CH3 groups attached to the nitrogen. But nitrogen cannot have more than 4 bonds, more than 3 bonds. So nitrogen usually form 3 bonds with there's a lone pair, maximum up to 4 bonds, like NH4, OH. So this is N dimethyl. N comma N, there are 2 methyl groups, so we call it dimethyl. N dimethyl. Dimethyl. So this longest chain, so this one has how many carbon? 1, 2, 3. So then it's become propanamine. Propanamine. Okay. Can you try the sixth one without my help? Can you try first? Then after that I'll write it. Okay, so you have given N-ethyl, N-methyl, yeah, because alphabetical order also, yeah, that's good. You have considered that also. N-ethyl, N-methyl, no, very good. N-ethyl, N-methyl. After that, propanamine, 1, 2, 3, yeah, correct, very good. Propanamine. Right, the next one, number 7. Number 7, can you try? This one can try this also. N-methyl, you can write the number. Oh, there's a side group also. Okay, be here, be careful. 1, 2, 3, 4. Butanamine. Can try first. Right, you have given N-methyl, N3-dimethyl. Correct, very good. Yeah, you have got it. N comma 3, the third one there's a methyl group attached, so therefore N comma 3 dimethyl. Because by looking at the name, if we give this name to someone, then they should be able to get this structure again by looking at this name without any confusion. Dimethyl butanamine, no? Very good. No space between methyl and butanamine. Next one. Next one also can write this at the eighth one. Yes, first you try, then after that I'll write. Right, so you get here. Okay, that's correct. Only thing is this that N-methyl should come first because we give that one is that one anyway we are writing that first name. So the groups attached to the directly to the nitrogen we have to write first. Otherwise everything else correct. So this ethyl group, methyl group, and this ethyl group is there. So you can write here N-methyl. Anyway. Because this one is not a side group here because it's directly attached to nitrogen. That's why we write here N-methyl. N-methyl. Then 2, if we write the number in here 1, 2, 3, 4, 5, and then 2 ethyl, the second carbon ethyl group, 2 ethyl, 2 ethyl pentanamine. Pentanamine. Okay. After that, number 9. I think you want everything okay, pentanamine. So that's the only thing. A small change. The last one. What about this? Can you try this first? Last one. Okay, so you have put N-ethyl, N-tridimethyl, 4-phenyl, pentanamine. Very good, perfectly correct. Yeah. So I'll write it for the others. First, you have tried his ethyl group, ne? Yeah. Ethyl methyl, no? Ethyl methyl. They are direct attached to nitrogen, and then you get methyl, and this is phenyl. Yeah. You can write here N-ethyl, and this also methyl here. This also methyl. Then N-3 dimethyl. Then numbering, if you get here 1, 2, 3, 4, 5, 4-phenyl, 4-phenyl, 4-phenyl pentanamine, no? 4-phenyl pentanamine. Right. So that's the last one. Okay, so I think now we have done all the IUPAC names. So it's 7:30, so I will stop for now. This is the summary. I have given that two important things, so that in the resource book that you will remember. That also I have given here the the priority order, and so this one for homework is at now. This one. So you have this, right? This one, try to do all the possible ones, and the next day I'll discuss this. Right? Okay, then we'll stop for today. Good night and God bless you.